Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get started. Let's take a look at the homework for 1.1.2. First off, we've got the M&Ms for perimeter and area. Now, I want to remind you, these M&Ms replace the standard notes that you would normally be taking during class time. During class, we're doing activities. I'm not necessarily bogging you down with formulas and definitions and diagrams for you to copy down. That's where the M&Ms come into play. The great thing about the M&Ms is there is no problem solving happening here. It's simply a matter of you recording this information in your math notes. So the more detail and the neater you are with putting your M&Ms in your math notes, the better a tool this will be if you ever need to go back and look something up or reference things. Like, how do we find the perimeter of a shape? Well, the perimeter is the distance around a shape. So you would take all the sides of your polygon or whatever your shape happens to be, and you'd add those lengths together. So the perimeter of this would be 5 plus 8 plus 4 plus 6, which is 23. If you're talking about a figure such as this, I often have students that start in one corner and then work their way around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the distance around is a total of 20 units. Area is where you are actually measuring how much space something takes up on a flat surface. So the best way to measure this is how many squares would it take to fill up this shape. And remember, a square has 4 equal side lengths. And whether they're square inches or square centimeters, square units, square anything, you would just denote these as squares. So for instance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We don't know if those are centimeters or inches or meters or miles or whatever. So if they don't have any unit of measurement, we'll just call them units, and these would be square units. Here is a 3 by 5 rectangle, so this would be filled up with 15 total square units. And sometimes, most of the time, when we see the rectangle, we don't see the individual squares, and we just know that to find the area, you multiply base times height. So this is the generic formula for finding the area of any parallelogram, whether it's a rectangle, whether it's a square, or whether it's this kind of a parallelogram. When you're finding the area of a triangle is actually exactly 1/2 the area of a rectangle that had the exact same base and the exact same height. So if I were to take this triangle and take this section of it and double it, this section right there would be the same as this, right? And this section right here would be the same as this. So the triangle's area is going to be 1/2 of a rectangle's area with the same base and the same height. Thus the formula. And then trapezoids have kind of a unique formula. It's kind of interesting how this works. This one isn't like perfect for the diagram of how this works, but essentially what you do, let me just get rid of all this here. Essentially what you do with the trapezoid is you take the average of your two bases, and your two bases are the two sides that are parallel to each other. So add them together and divide by 2, or add them together and take half of it. That's an average right here. The average of the two bases times the height. And what essentially you do is once you find the average of those two bases, this essentially turns into a rectangle if you were to cut these pieces out and maneuver them around. When we get to some of those examples that are easier to show, I'll show them to you. All right, so find the perimeter and area of each of the figures below. So here are the answers. Remember, find the area of a triangle, you had to multiply 1/2 times the base times the height. And to find the perimeter, you take the distance around it. Most common mistake people make with the perimeter is they include this 4 inches because they have to add all the numbers together. But no, it's just the numbers for each of the side lengths. This is not a side length. That's the height. of the triangle that is required for when we find the area. Here's a trapezoid, the average of the two bases, that would be 35, half of that is 17 and a half, and multiply that times 12, you'll get the area. And then the perimeter, once again, is the sum of the four sides that make up the perimeter. And then here's a parallelogram, base times the height. Now, people might think that the 7 is the height and the base is the 4 because heights go up and down and bases are at the bottom. But it's really important for you to understand this. The base and the height are perpendicular to each other. So it doesn't matter that this trapezoid has, no, it's not a trapezoid, this parallelogram has been rotated 90 degrees. This is considered the base and this is considered the height. Those are the two sides that are, or the two measures, I should say, that are parallel to each other. And then another common mistake students sometimes make with perimeter is, since this is a parallelogram, we don't necessarily need to say that that is 7 and this is 4 yards. But you need to know that for when you add in all the sides. Some people accidentally only say 11 yards because they only see this guy and this guy right there. But you got to understand, you're measuring all 4 sides of that parallelogram. Okay, so I did not go into detail showing any of this work. If you need me to show work during the time in class when you see me and you need to ask questions about the homework, please ask me these questions, okay? I understand you're at home watching this video. You're not at school. If we're doing distance learning, then you can Google Meet with me and we can talk about any of these problems, okay? Think about games that you can remember playing with your family or friends. Talk with your family or friends and list as many games as you can think of. Label each game on your list as fair or unfair or I'm not sure. Okay, this is kind of tough. Maybe what we can do is people can volunteer some of the games that they came up with. In the past, we often play card games in our family. We like to play Monopoly. What other games do we like to play? We like to play Connect 4. What other games do we like to play? Oh, there's this one game that we call Otrio, which is kind of a, it's a funky kind of a tic-tac-toe kind of a game. And you know what? All of these games are fair games. The reason why they're fair games is because as long as you know the rules and how to play the game, everybody has an equally likely chance of winning the game, depending on which cards you get, depending on where the dice roll and how many times you land on someone else's property and have to pay them rent. Whether or not you understand strategy for Connect 4, there's only red and black pieces, and everyone gets a chance to go at their own term. So there's no reason why that would be unfair. And Otrio is just like tic-tac-toe. Generally, the first person who goes in tic-tac-toe has an advantage, but if you know how to stymie the other person, then you can always get a game that's a cat game. So all of them are fair game as long as you understand strategy. All right, each of the following pairs of events, predict which one is more likely to happen and explain your reasoning. So for A, you will win more than $1 million in a lottery sometime in your life, or you will learn to speak a language that you do not already know. Now, these are always great for discussion in class because you always get some arguments. I guess I chose event number 2 because you have control over this. If you want to, if you make it a goal to learn how to speak a language, nothing can stop you from learning how to speak that language. You just got to work hard until you get it right. However, winning the lottery, first of all, you got to play the lottery, but even if you play every single week, there's no guarantee that your numbers are going to come up. You have control over event 2, not event 1, which makes 2 more likely. Event number 1 for B, your classmates will all wear the same kind of shoes on the same day. Or event number 2, your classmates will all eat the same thing for lunch on the same day. Well, first of all, the odds of everyone in your class even owning the same kinds of shoes are kind of strange, although one might argue when they say same kind of shoes, you might say tennis shoes. When in that case, I would agree that on PE days, everyone is wearing tennis shoes. So maybe that one is the more likely event. But what I was thinking is all wear the same kind of shoes. It's like the same brand, same kind of shoe. Whereas on number two, there are days like when we go on field trips or when you go to science camp, outdoor science camp, where everybody's eating the exact same lunch. So this does happen a few times per year with all of your classmates where you're all eating the exact same thing. So that's why I chose number two. But once again, these are up for debate. It's good to have conversations and present your ideas of what you think is right. All right, so copy the number line below onto your paper. Place a point on the number line and label the point for each of the following numbers. So this is meant to illustrate that when we have to order numbers from least to greatest, and some of our numbers are negatives and some of them are positives and some of them are either fractions or decimals, finding their home on a number line is how you put these in order from least to greatest. And so once we've got every one of these in their home on the number line, now you know, okay, the lowest number is -4, then -3.5, then -2, then 0, then 1/2, then 1, then 3, then 5. That's the order of these numbers from least to greatest. And then problem number 15, Maria was playing a game with her brother. She said, I'm thinking of a number. When you multiply my number by 6 and 7, you get 25. What is my number? Okay, so if you think about this, if we solve this algebraically, we would say, all right, I'm thinking of a number. I'll just use x for my number. And when you multiply it by 6, so 6 times my number, and then add 7, you get 25. So I guess the first thing I would want to do is think, what number do you add to 7 to give you 25 for an answer? Wouldn't that be 18? Since 25 minus 7 is equal to 18, which means that the 6x has to be equal to 18. And now, what number do you multiply times 6 to give us 18 for an answer? And that's 6 times 3, right? Because when you take 18 and divide it by 6, you get 3 for an answer. So you can always check that to make absolutely certain that that is correct by plugging it in and say, all right, I'm going to multiply my number times 3, that's 18, then add 7, that gives me 25. Yeah, we get 25. So we feel confident that this is the correct answer. Where are we? Do we have more? What's going on here? I won't advance. Oh, I guess we're done. Okay. So, good job on your homework. If you made any mistakes, feel free to correct them. You're not getting marked down for any mistakes. You're actually learning from making the mistakes and analyzing those mistakes and making the corrections. So keep at it. 12, 13 minutes, ooh, longer than I wanted it to go. Okay, I'm gonna go. Take care. Bye. Bye.
Hey, feeling good, like I should. Winning